Okay, so D is a subset of A, and we want the cardinality of D to equal 2. So one possible outcome, and there are a number, is that A could be lions and tigers. The question is, how many possible arrangements? Well, really, this is just a simple combinations problem because the order does not matter. So there were 3 elements in A, and we're choosing 2. So this would be 3 factorial over 1 factorial times 2 factorial, which is 3 ways in which we can have D be a subset of A and have its cardinality be 2. Okay, the next one is find A union B union C. So we know that we're just looking for all of the things that they share. So A union B union C, let's call this set D. So our new set D is going to be lions, tigers, bears, and computers. So now we're into set B, water bottles, apples. Now we're into set C, math. We already have tigers and bears, and pizza. And we want to know how many are in there. So 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality of our set D is 8. In this problem, we want A union B union C and, so joint, all the things that are not B. So from the last one, we had, lions, tigers, bears, computers, water bottles, so we have lions, let's write it out, tigers, bears, computers, water bottles, apples, math, and pizza. But we want this to be joined with, so it must also have all the things that aren't B. So it can't have things that are B. So therefore we need to get rid of anything that's in B, which are lions, computers, water bottles, and apples. So our set then is just tigers, bears, math, and pizza. All right, now we want to find A, B, C. We want to use A, B, and C and find some empty set. So an example of that would be B joint C, because they don't share anything in common. So this equals the empty set. All right, now we want D to be a subset of B, and we want the cardinality to be 3. You can also write cardinality as like hashtag parentheses D, close parentheses. These statements are equivalent. They're just 2 different ways of writing it. So an example of that could be that D equals, we need 3 elements, so let's just choose our first ones. And the question is, how many combinations will satisfy this? This is similar to that other problem that we were doing before. B has 7 elements, and we're choosing 3 where the order doesn't matter because the order in the set doesn't make a difference. So this would be how many we have. Now just to go through that, we have 7 times 6 times 5 times 4 factorial over 4 factorial times 3 factorial. So the 4 factorials cross off, the 3 factorial crosses off with a 6. So there are 35 ways that we can choose 3 elements from B. Okay, so now we want A union B joint C. So the fact that it's joint C, what we realize is that C only has 3, 8, and 14 in them, and 3 is contained in A, and 8 is also contained in A, and 14 is contained in neither. So 14 doesn't exist in A or B. So A union B joint C is just going to equal the elements 3 and 8. Next question says, what's bigger, A union B or C union B? Well, if we just write out the sets, we have, let's see, the elements being 2, 8, 12 in A union, in A union B. Whoops, I was doing A joint B. So this is going to be 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so that's a size 11. And C union B, here we just have 2, 3, 5, 8, 9, 11, 12, 13, 14, which is size of 9. That shows that A union B has more elements than C union B. All right, in 8, now we're starting to get into some set notation, or at least I'm writing it as set notation. So it says find all elements in the set made up of, so we're looking for all elements X such that X is composed of 2m plus 3, where m is a natural number, so I'm saying m is an element of a natural number, and this symbol here means and X is less than 5. So we're saying natural number, I'm defining it as starting at 1, so we have 1, 2, 3, 4. Therefore, X is going to be putting these values into our equation. X is going to be, let's see, 5, 7, 9, 11. Okay, so for number 9, very similar. It says find all elements of the set. So we're looking for all X values such that X equals 4m squared minus 1, and m is an integer, so m is an integer, and greater than negative 3 and less than 2. So we'll say negative 3m 2. Close that up. So that means that our m values are going from negative 2, negative 1, 0, 1, and we're putting these m values into this expression to get new x values. So we're calling on a function to create new sets. So what do we have? We have 15 and 3 and negative 1 and 3 for my x values. All right, in 10 it says find all elements in the set made up of x values. So we want a set made up of x values such that x is 2. So again, we have our m values are negative 2, negative 1, 0, 1, and these m values are going to create some new x values. So x can be 2 to the negative 2, which is 1/4 plus 1, 1.25, negative 1. So we have 2 to the negative 1 is 1/2, so 1.5, 2 to the is 0, it's 1, so 2, and 3. All right, so in 11, we've got 5, 7, 9, 11. And using the language from before, we'd say something along the lines of, what could we say? Well, it's all x such that x equals, well, this is a linear relationship, so 2m, and let's have our m's value be 1, 2, 3, 4. So this would be 2m. If I put 2 in when m is 1, we need to make this plus 3. So x such that x equals 2m plus 3. And m is a natural number less than 5. Okay, in number 12, we've got the numbers 2, 4, 10, 20, 34. And if we look at them, we're changing by 2, and then by 6, and then by 10, and then by 14. Well, that's not linear, but if we look at the change of those, I'm changing by 4, 4, 4. And if I do a little bit of solving, and we'll figure out better ways of doing this, but for now, I want you to kind of puzzle around with this. The way that I'm going to think about this is my change is twice what it normally is for a quadratic. So I'm going to have 2x squared. And if I just try some values, if I've got 0, I would get 0 here. And if I put 1 in, I would get 2. And if I put 2 in, I would get, let's see, 8. So this is just shifted down 2. So if I added 2, these would be 2, 4, 10. And the pattern sort of continues and works. So what we'd get is x such that x equals 2m squared plus 2, where, let's see, where m, we could say it's an integer and it's between 0 and, how many terms are there? 5. So between 0 and 4. Let's just make sure that works. The fourth term, if I put in when m equals 4 into here, I would get 2 times 4 squared plus 2, which is in fact 34. Okay, and in 13, what we're doing is we're saying we've got the numbers 5, 15, 45, 135, and this may jump out at you right away. If we just look at the ratios, 15 over 5 equals 3, 45 over 5 equals 3, 135 over 45, also 3. So therefore, this is an exponential growth, and what we're doing is we're starting off by 5, and we're growing by 3, so 3 to the, let's say 3 to the m. So we're talking about all x such that x equals that, where, let's say, such that m is an integer, and m is less than or equal to, sorry, let's write that differently. Zero is less than or equal to m, which is less than or equal to 3. And let's just check that out. I'll look at the last term. When m equals 3, we have 5 times 3 cubed, which is 27 times 5, which gets us to where we want to be.